Hi friends, today I am going to teach you about the simplex method. Simplex method. Now the basic of simplex method is set. Let us take an example. Set equal to 4x1 plus 10x2. This set is called as the objective function max, and subject to will be given as 4x1 plus x2 less than or equal to 50 and 2x1 plus 5x2 less than or equal to 100, 2x1 plus 3x2 less than or equal to 90. So these three are called as constraints. Now if you have max, then the symbol of the subject to should always be lesser than. Now in this example it is lesser than. Consider another example like max z equal to 4x1 plus 2x2 plus 6x3, and this is objective function, and subject to will be 2x1 plus 3x2 plus 2x3 less than or equal to 6, 3x1 and 4x2 equal to 8 or lesser than or equal to 8, and 6x1 minus 4x2 plus x3 greater than or equal to 10. Now the question is max and everything have to become lesser than. These both are lesser than, but the given constants, these are called as constants that I have already said, is greater than. So what we have to do is convert this as lesser than. So multiply this equation by minus 1. So we will be getting as 2x1 plus 3x2 plus 2x3 lesser than or equal to 6, the first equation, 3x1, 4x2 lesser than or equal to 8, and by multiplying the third equation by minus 1, we'll get minus 6x1 plus 4x2 minus x3, and the symbol will be automatically changed less than or equal to 10. By this we have converted the greater than symbol into less than symbol. So these are called as constraints. So the basic formula is, if maximum is in the objective function, then the symbol should be always lesser than or equal to. If it's minimum, then the symbol should be always greater than or equal to. So let us consider a small example. Example 1. So max, the question is being maxed, and 4x1 plus 10x2 subject to 2x1 plus x2 less than or equal to 50 and 2x1 plus 5x2 lesser than or equal to 100 and 2x1 plus 3x2 is other equal to 90 and x1 comma x2 greater than or equal to 100. This is a given example question, and from this we have to calculate the simplex method. So next, step 1. In this we have to introduce the stack variables. Which is max z equal to 4x1 plus 10x2 is a given objective function, and subject to we have to convert the less than or equal to into equal to. So we have to add a stack variables. Stack variables are nothing but s1, s2, s3 and etc. Now we'll be adding the stack variables. So 2x1 plus x2 plus s1 equal to 50 and 2x1 plus 5x2 plus s2 equal to 100 and 2x1 plus 3x2 plus s3 is equal to 90. Now we have inserted the stack variables, that is s1, s2 and s3. Now we have to insert in the maximize, that is our objective function. So we'll be inserting as 0s1 plus 0s2 plus 0s3. Now and at last we have to mention x1, x2, all the variables, that is x1 and x2 and s1, s2, s3 greater than or equal to 0. Step 2 is identify the basic, initial or the feasible solution, that is identifying the basic variables. The basic variables are nothing but which is in the constraint table. So s1 equal to 50, s2 equal to 100 and s3 equal to 90. This will be called as the basic variables. Next, step 3 is construction of initial iteration. So for iteration we need to know two formulas. Zz equal to summation of CB into AIR and theta equal to XB by AIR. The basic formula are this one. While constructing this first iteration, I have already created a tabular column. So this basic variable should be already given. So please by heart it. So CB, YB, XB, X1, X2, because the given question has only X1 and X2. If X3 is available, then we have to add X3 also. So there's no X3 over here. So I have written till X2. And the stack variables which I have already added is S1, S2 and S3. Finally the theta. So CB is nothing but the stack variables in the objective function 0, 0, 0. Next, YB. YB is nothing but the stack variable representation S1, S2 and S3. XB is the basic variables, which are this one. So 50, 100 and 90. And so here, so you can see the given question here. And then x1 is the given coefficient of x1 in the equation 1, that is 2, and x2 is 1. And we have added a stack value here. So after adding the stack value, we have the given equation as this one. You see here, S1. So in the first equation, S1 is available. So we can write 1 in the S1, S2 is not available, 0, 0. And second equation, 2, 5, 0, 1, 0. Third equation is 2, 3, 0, 0, 1. So after this, we have to calculate our Cj. Cj is nothing but on the top of the xb, just write Cj, and Cj is nothing but the objective functions, coefficients of the objective function. You see the coefficients of objective function. 4, 10, 0, 0, 0 is the objective function. So 4, 10, 0, 0, 0. After this, just consider this row as L1, L2 and L3. After this, we have to find Zj. So Zj is nothing but, I've already said, Zj is equal to Cb into AR, that is XB Cb into AR, the given column. 0 into anything, 0. 0 into 2, 0. 0 into 1, 0. 0. Everything will be 0. Theta will be calculating later. And then Zj minus Cj is, Cj is being here. So we can calculate Zj is 0, and 0 minus 4 will absolutely be minus 4, and minus 10, and 0 minus 0, 0, 0 and 0. Now in this we have to find the entering variable and the leading variable. To find the entering variable, we have to take the largest negative value from the Zj minus Cj. The largest negative value is 10. So that row will be called as the entering variable. And to calculate theta, I have already said that theta equal to xb minus by AIR. xb by AIR. That is, divide this by this. So 50 divided by 1 is 50, and 100 divided by 5 is 20, and 90 divided by 3 is 30. So in this we have to calculate the leading variable. Leading variable is nothing but the lowest positive number, which is absolutely 20. So if you go straight over here, our pivot value, this is called as pivot value. We can identify our pivot value. From this, just check whether the Zj minus Cj is being positive. No. If it is not possible, we have to go to another iteration in this tabular column. In this next iteration, we have to make our 5 into 1 and these 2 as 0. So how to make that? So next iteration will be, so consider these as L4, L5 and L6. So in this, which we have got is x2. So we have to substitute the stack variable into x2. We have to transposition these both. So x2 in L5 and same S1 and S3 sorry. Now if we want to calculate L5, then the given formula will be L5 is already L5, L2 is 5. We have to convert this as 1. So if we divide it by 5, it will become 1. So L5 equal to L2 divided by 5. So next to L5 will be 1 and we will be dividing everything by 5. So in this 100 divided by 5, 2 divided by 5 and it is already 1 by 5 and by 5. So 100 divided by 5 is 20 and 2 divided by 5 will be always 2 by 5 and 1. 0 by 5 is 0 and 1 by 5 will be always 1 by 5 and 0 by 5 is 0. Now coming to the next equation, L4. So we can calculate L4 as already there is 1. So we want to make this 1 as 0. We have calculated L5 as 1. So if you minus L5 into L1, we'll get this as 0. So the equation will be L1 minus L5. So if we minus this one by this or the L5, we'll get the given equation. So L1 is 50 minus 20 is 30 and 2 minus 2 by 5 is 8 by 5 and it will be 1 minus 1 is 0 and 1 minus 0 is 1 and 0 minus 1 by 5 is minus 1 by 5 and 0 minus 0 is 0. Now we've got L4. Now coming to L6. L6 will be, now our L3 value is 3. So we have to make this as 0. So our pivot element we've already made it as 1. So if you multiply this L2 into 3 minus L3, we'll be getting the L6. That is L6 equal to L3 minus 3 into L5. 3 into L5. So the given equation is, so L3 is 90. So 90, L3 is 90 minus 3 into L5. L5 is already 2 by 5. Sorry, 20. So the given answer is 60 minus 90 equal to, it is 30. So by this we can calculate all this one. So 2 in minus 3 into 2 by 5, that is 6 by 5. 2 minus 2 by 5 is 4 by 5, and absolutely this will be 0. And next, 0 minus 0 is 0, and minus 3 by 5 and 1. So calculating the Cj equal to, we have to first put this one 0 and calculate the Cj equal to 4, 10. We've already written, which is in the objective function 0, 0, which is in the x2 we have written here. So we have to write 10 here also, and then 0. And then the given equation will be 10 into 20 is 200, and 10 into 2 by 4 is 4, 10 into 1 is 10, 0, 2, and then 0. So Zj minus Cj equal to 0, 0, 0, and 2, and 0. Zj minus Cj is 0, and 4 minus 4 is 0. 10 minus 10 is 0. Now we have already got all positive numbers here, so we no need to add theta over here, and there's no iteration over here. The next given answer will be calculating as what is near Zj is 200. So Zj equal to 200, and is there x1 in this? There is no x1 over here, so absolutely x1 will be 0, and x2 is 20, so we'll be calculating as 20. So by this we can calculate the simplex method. Thank you.